All right, so section 2.2 here. Hi. Okay, powers of 10 and the exponent 0 is what we're going to focus on here today. Powers of 10. So that would be a base of 10. And exponents that are 0. Okay, so we talked a little bit about last lesson. Somebody brought up 0. Is that frozen? Thank you. All right, so let's fill in this chart together. We're going to write each of these powers here as repeated multiplication in standard form, just as a bit of a refresher. And it's going to, we're going to establish some kind of pattern here in these answers as well. So 3 to the power of 5 is 3 multiplied by itself how many times, guys?
5.
Right on, 5 times. So let's see, 1, 2, 3, 4, 5. Okay, standard form, what is that? Okay, let's see if we can do this. So 3 times 3 is 9. There's another 9 there. What's 9 times 9? Okay, 9 times 9 is 81. 9 times 3 is 27. 27 times 3 is 81. What's 81 times 3? Oh, that's a tough one. Again, we're trying to do this without a calculator. So 3, okay, there we go. 243. So in standard form, this is 243. Awesome. Okay. What about the next one? Well, this is going to get easier, I think. 3 times 3 times 3 times 3. That's 4 times. What's that answer? Well, as we said, we're going to group those 3 by 3s together. So that's 9 times 9 is 81. Awesome. All right. 3 times 3 times 3 is 27. Very good. 3 squared, we know, is 3 times 3. And that's going to be 9. Great. And 3 to the power of 1 is just 3 times itself like 1 time. So it's just 1 3. That's 3 to the 1. Now, I think this was a question that we had last day, right? Just the regular number 3, what is it as a power? And some said 3 to the 1. Some said maybe 3 to the 0. They're both good questions, and I asked you to think about that. So now we kind of know, and this is leading us into discovering what 3 to the power of 0 might be. So first of all, let's pause right here. What patterns do we see? There's as many patterns as you can tell right here. Tell me what you see in this chart here. I'll just erase some of these lines. Any ideas? What do you see? Yes?
Each one gets 3 times bigger.
Okay, so when we work up from the bottom, each number here gets 3 times bigger. Or if we work from the top, each gets 3 times smaller. So when we say 3 times smaller, how else can we say that? It's being divided by 3. Yeah, very good. Being divided by 3. So going down, we're dividing by 3 each time. Now, over here, another pattern that you might notice is that the number of 3's being multiplied in every row going down decreases by 1, right? So it's kind of like we're knocking off the end 3 to get the next row below. This one, we're knocking off that last 3 to get the next row, and so on. So that's another way to think of dividing by 3. Dividing by 3 would be like removing a factor of 3, right? Now, that's really important for when we factor, because factoring is super important in high school. Probably the most important math skill in high school is being able to factor, being able to split a number or an expression or something like that into the parts that are multiplied together to make that. That's the most important thing in all of high school, factoring. So whenever you have a factoring exercise or an assignment, please take careful note of it, because when you get to me in grade 12, when we're doing calculus, there's a lot of factoring that you're going to need to do just like that, and it starts now. You guys can do it, all right? So just a little spoiler alert. Okay, so divide by 3. Look at over here on the right. I'm going to zoom into this a bit on the right here, okay? If I keep dividing by 3 here, 27 divided by 3, 9 divided by 3, the pattern, one more pattern that you might have seen is that the powers here, the exponents of these powers, are decreased by 1 each time, okay? So because those go down by 1 each time, the number of 3's being multiplied is down by 1 each time. And in standard form, we understand those values as being divided by 3 each time. This will help us come to what is 3 to the power of 0. So let's just take a moment and jot down what we talked about in the patterns. Okay, I'll help you with that. All right, so once again, we said that each standard form of the number gets divided by 3 each row as we go down. The exponent on the far left side here of the power gets decreased by 1 each row we go down. And the repeated multiplication always has 1 less 3. 1 less 3. Okay, so we're going to be able to use these patterns now to figure out what happens with 3 to the power of 0. So let's put it all together. Question? Good. Let's put it all together here now. Notice that if this pattern continues here, we're going to have 3 to the power of what in this row below? Yeah, it's going to be 3 to the power of 0 here. All right, so I'm really interested in what the rest of these are going to be. This one might be a little bit tricky, like what goes here, right? Because there's like nothing there. 1 3 here, there's 2 3s there. So 0 3s here. So this one is a bit tricky, but this will be the key. This is the key to what 3 to the power of 0 is. If I keep dividing by 3, what is 3 divided by 3?
1.
It's 1. Okay, it's 1. So when we have 3 to the power of 0, that is 1. So 3 to the power of 0 equals 1. Doesn't equal 3. That's what 3 to the power of 1 equals. Instead, it equals 1. Now, I did mention last lesson that when we get to the exponent laws, I'll be able to explain this a little bit better. This is one way of explaining what 3 to the power of 0 is, but I'll be explaining that again when we get to later exponent law. Now, the cool thing about this is, guys, is that we can have anything, any number, let's say 4, okay? If we did 4 like this, we would be able to use the same patterns. Let's just do 4 here real quick. So 4 to the power of 3 is what, 48? 16 times 3, 48. 16, 4. And so if I divide by 4 each time, what's 4 divided by 4? 1. Well, that's 1 too. That's 1 as well. Okay. Guess what? If we change the base, the patterns are all going to continue. This can be anything. It can be any base. And we're going to have 1 on the bottom row. So 3 to the power of 0 is 1. 4 to the power of 0 is 1. Guess what 5 to the power of 0 is? 1. Guess what 17 to the power of 0 is?
1.
Here's a tricky one. What about 4,562 to the power of 0? Whoa, that was quick. Yeah, that one's 0. No. So any number or variable or quantity to the power of 0 equals 1. Unless the base is 0, that's the problem. Okay? So let's take a look at this rule here. I think you have in your notes a place to fill in some blanks here. The 0 exponent rule. Any base excluding 0. So 0 doesn't count. And when you get to calculus, we'll talk a lot about 0 to the power of 0. Okay? But we won't do that now. Any base excluding 0 with an exponent of 0 is 1. So I used x above. They use a here. Anything to the power of 0 equals 1. All right. Complete the table. All right. Well, we've done this example with 3, and I've done this example with 4, so this shouldn't take very long at all. Let's do this quick. Actually, you know what? Let's start at the bottom. I'm going to start at the bottom. This is 5. This is 5 times 5. This is 5 times 5 times 5. And this is 5 times itself 4 times. So we have 5 here. We have 25. We have 125. And we have 625. Right? The value of 5 to the 1 is 5. The value of 5 to the 0, 1, because we divide by 5 each time in this row. Or if you think about going up, we multiply by 5 each time. So what number times 5 gives you 5? Well, it's 1. Okay, so 5 to the 0 is 1. Awesome. Any questions about that? Okay, that's a number of examples of the same concept there. Okay, identify the base and then evaluate the answer. So here's example 2. Identify the base and evaluate the answer. All right, what is the base for A? 5. The base is 5, and what's the answer? 1. Nice. What's the base here?
10.
Base is 10. What's the value of this answer? 10 to the power of 0 is? 1. Very good. What's the base for 3? It is -5. Very good. Thank you for saying negative and not minus, too. You guys are catching on, right? It's a -5. Very good. Very good. I like it a lot. We haven't done an example like this. What do you think that -5 all to the power of 0 would be? Would it be +1 or -1 now? Is there a difference? Negative? Okay. Okay, let's just double check this. Let me see. If we did -5 to the power of 3, if I did -5 to the power of 2, -5 to the power of 1, and then -5 to the power of 0, what are the standard values here? This is going to be -125. This is going to be +25. This is going to be -5. So what's happening here? We are dividing by -5. So what happens at the end? If I divide by -5, this is going to be positive or -1? +1. So any base, even if it's negative, to the power of 0 is +1. Yeah, that's right, because this negative is involved every time, so the signs alternate. You see, when multiplying or dividing, the signs, whoops, the signs alternate. I don't know why I made that a plus. Here. So that becomes +1. Now, D is tricky. This last one on this side, D is tricky. Why? Because what is the base? +10. The base is +10 because, look at the comparison here. This one has brackets, including the negative sign, so that negative sign is part of the base. D does not have those brackets, so remember what this means is that the 0, or the exponent, only applies to what is immediately before it. If there's no brackets, like this one has brackets, so the 0 applies to everything here. With no brackets, it just applies to the 10. So the base is 10, and this would be like the value is 1, because 10 to the power of 0 is 1, but then you have this negative sign over there, so the value, the answer here is -1. I'll let you take another look at that. You see the difference there. Okay, that negative sign is outside of the base. It's not included in the base. Okay, any questions about that? Well, everybody's okay? All right. Okay. Do you guys remember the order of operations? Remember order of operations? Okay, I always use this handy little memory mnemonic here of bed mass. Do you guys use that one too? Yeah. Okay. Okay, good. Yeah. So, okay, so the order of operations says that we deal with anything inside the brackets, we have to evaluate that first. And I just mentioned that brackets and parentheses really treated the same thing. The round brackets, square brackets, they're the same thing. So anything inside the brackets we would evaluate first. Then we move to exponents. E is for exponents. If we had an exponent, we would evaluate that then next, after the brackets are done. And then after that, the D and the M is division and multiplication. So those two you can do however that appears from left to right. Okay, so just do your first one. If it's multiplication, you do that. You evaluate that first, and then you move on. If it's division, you do that second. Okay, whichever one comes first, left to right. And addition, subtraction would be the last category, and you can do either one of those, whichever one comes first, left to right. That's what we do last. All right, so you've had lots of practice with this in previous years. Let's make sure we remember that when we evaluate these expressions here. Okay, So we have 3 plus 2 to the 0. So should I do 3 plus 2 first?
No.
No, and that's because addition is way at the end, and we have an exponent here. We have an exponent part that we should do first. So very good. We do not do 3 plus 2 first. We do 2 to the power of 0 first. And what did we learn that 2 to the power of 0 is? 1. So that's actually 3 plus 1. Very good. And the answer then is 4. Awesome. Showing some work, circling your answer. Love it. Okay. So again, I'm not going to do 3 plus 2 here first. I'm not going to do that. I'm going to evaluate the exponents. There's no brackets. I'm going to do the exponents first. This is a 1 plus 1. 2. All right. Okay, what about C? I'll do C with you as well. So should I do the exponent first, or should I do the brackets first? Yeah, brackets first. So I'm going to evaluate what's inside the brackets first. So that 3 plus 2 is 5. And then, so you just rewrite the 3 plus 2 as 5, and then you keep the 0 up there so you know what to do next. Okay? Notice how when I did one part here, I evaluated that one part, but I left the other parts of the equation, I just rewrote them. Okay? So I want you to do that. When you change one thing, rewrite the other things as well in showing your work, because I have students that do this. I have students that do something like this, and they go, okay, I got to do this one first, so that's 1. And then they get distracted for even a second, and then they say, oh yeah, okay, I'm done. And they forget about the 3. And that happens, especially when you have like multiple rows of work. So please try not to just do one thing at a time and forget about the other stuff, because when you get down the page, you might forget about it altogether and get the wrong answer. So that's why I always encourage, evaluate what you need to evaluate first, but make sure you write the other stuff each line. Okay? So that's why I did this. 3 plus 2 is 5, and then I make sure that I remember I got to take that to the power of 0, which is now 1. Okay? You guys good with that? Okay, why don't you do D, E, and F on your own and see if you can do those. Remember this bed mass here. I'll bring that over a little bit. Okay, take a moment and do that. Okay, so here's your answers, and oops, I think that something disappeared on me here. Let me do E again for you. So remember, without brackets, for negative 3 to the power of 0, that's actually negative 1 plus 2. So if you have a negative 1 and you add 2 to that, you go up to 0 and then to a positive 1. Over here, this is negative 1 plus positive 1. So that gets to 0. F is, we do brackets first, so that's 5 to the power of 0, but that negative sign is outside the brackets. So 5 to the 0 is positive 1 times negative, we have negative 1. Okay. Any questions about that? Those are tricky. Those last 3 were tricky. Any questions about how that works? Okay. All right. All right, let's move to powers of 10 then. Powers of 10. Write 10. What do we got? 10,000, 1,000, 100, 10, and 1. Write those as a power of 10. Now when it says power of 10, that means the base is 10. Okay? The base is 10. So what you want to remember is, how many times do I have to multiply 10 by itself to get the number? So I'm going to start actually over here at D. Okay? Let's start over here at D. How many times do you have to multiply 10 by itself to get 10? Yeah, that's just 1. So 10 is 10 to the 1. Right? So any number to the power of 1 is just itself. So that one's pretty easy. We actually just got finished talking about this, right? So 10 to what power equals 1? We just got finished doing that. Yeah. Okay, so this is 10 to the 0, right? Okay. 100, think about a block or a square, 2, 3, 4, 5, 6, 7, 8. 10 squares, 2, 3, 4, 5, 6, 7, 8. 10 by 10. right, is 100. So 100 as a power of 10 would be what? 10 to the power of? Well, not 10 to the power of 10. I think I heard 10 and I heard a 2, but it's 10 to the power of 2. It's 10 times 10, right. Okay. 1,000. Ooh, 1,000. Did you know that if we drew this square of 100 units, which is super messy, but if we drew that square and we made it into a cube, guys, made it into a cube, and we went, hey, we're going to go 10 units this way and this way as well. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I do 9 lines because there's a space on the left side of each line, plus there's 2 space on either side of the last line, so that's what makes 10, right? So if we could envision this cube, that's 10 by 10 by 10, and that would be 1,000 little blocks in there. So what's 1,000? It's 10 to the power of 3. Very good. So 10,000, what do you think, would be 10 to the power of
4.
It is, because that's 10 times 10 times 10 times 10. Okay, what pattern do you see in these powers of 10? What's the big deal here? Michelle?
That each time there's another zero,
Okay,
add an exponent. You
okay.
add 1 to the exponent.
Okay, very good. So each time there's another 0 in the power of, in the 10, or in the power of 10, these multiples of 10 is what they are. So each time there's another 0, we would add an exponent. Very good, yes. Does anybody else see a slightly different pattern or even a different way of putting that same thing?
If you count the number of zeros behind the 1, that's the number, like the exponent.
Excellent. Yeah, if you count the number of zeros behind the 1, that's the number of the exponent. So both of those put together is absolutely correct. I like that a lot. So notice that 1 has 0 zeros, so that's 10 to the power of 0. 10 has 1 0 behind the 1, so that's 10 to the power of 1. 100 has 2 zeros, 10 to the power of 2. 1,000 has 3, 10,000 has 4. Okay, so let's write that down real quick here. The number of zeros behind the 1, equals exponent on 10. Okay, the number of zeros behind the 1 in the standard form equals the exponent that you would put on the 10. Exactly. So 10 to the power of 18 would be 1 followed by how many zeros?
18.
Yeah, 18. Okay. 10 to the power of 6 is 1 followed by 6 zeros. So let's take a look at this. Right, each number is a power of 10. I've got 4 zeros here, so this is 10 to the power of 4. This is a million. It's got 6 zeros. That's 10 to the power of 6. Well, not 7 because there's 7 digits, but there's 6 zeros. So you just count the zeros. All right, 10 million. 10 million. Well, we could write out 10 million, or we could say, hey, 10 million has 1 more 0 than 1 million. All right, 1 more 0. So 10 million is 10 to the power of what?
7.
Yeah, it's got 1 more 0 than 6, so 7. Very good. Okay, so the number 1 is 10 to the power of? 10 to the power of 0.
1.
Right? 1?
10 to the 1.
No, the number 1. This is the number 1.
Oh,
So the number 1 is 10 to the power of 0.
yeah.
Okay?
So that's
All right, what about this? This is 1 what? Let's see, 1,000, million, billion. That's 1 billion. So that's 10 to the power of what? 369. Yep, very good. And 10 itself is 10 to the power of 1. That's right. Okay, evaluate each power of 10. Notice that these negative signs are all outside. There's no brackets. There's no brackets. So 10 to the power of 6, what did we say that was? It's up here. 1 million with a negative sign in front of it. So it's negative 1 million. Now you don't have to put your little commas, but you can if you want. Make sure they don't look like decimal points or whatever. But you can use your commas. You don't have to. You can use little spaces or whatever. Okay. All right. So I'll tell you what. Why don't you do the last three on your own here? All right. So let me know if that's what you guys had. Okay, so they're all negative, and yeah, just put a 1 followed by however many zeros the exponent is. Okay, questions? Any questions on this? Yeah, hopefully this is making sense. Okay, one more thing we want to cover in this section here. The one thing we want to cover here is standard form. Now this is a little bit of a different way of putting this. This is like expanded form, I believe it's called. So also this is sort of an introduction. Oh, it's frozen? This is sort of an introduction as well to scientific notation. Have you guys studied scientific notation at all? Is that something that's come up in grades before? Okay. So yeah, so in science and math, we'll be using scientific notation to represent really large and really small numbers most of the time. It's just a kind of a convenient way of doing that. But anyways, this would be an example of scientific notation for a number. So standard form, of course, is just the regular number form. And in this expanded form that you'll see, we have, well, let's just do A first, okay? So 5 times 10 to the 4. Well, we know what 10 to the 4 is, right? That's 10,000. So 5 times 10 to the 4 is the same as 5 times 10,000. And 5 times 10,000 is what?
50,000.
Yeah, it's 50,000. Excellent. 50,000. Okay. Now, we get into some complicated, well, I don't know if it's complicated or not, but in this form here, we are adding different numbers, and this is going to come to one standard form number. So what we have here is 4 times 10 squared, which is given to you as 4 times 100. Now, what is 3 times 10 to the power of 1?
30.
3 times.
Yeah, that's 3 times 10. Okay, which is next step will be, we'll write 30 exactly. And what's 7? So what is 10 to the power of 0?
1.
Right. Okay, so when we get to this point, this 4 times 100 is 400 plus, and again, we're doing brackets first, right? So we'll do inside our brackets first, and then we'll do our addition later. This is 30, and this is 7. So in this sort of expanded form, what's the number that we are looking for here?
437.
Yeah, 437. Awesome. So the 4 goes in the hundreds spot because there's 400 involved here. The 3 goes in the 10 spot because there's 3 tens involved here. And the 7 goes in the ones spot for this standard number. Excellent. Okay. All right, let's do this one together, letter C. So this is 2 times, and I'm going to not use x, right? Like I'm trying to train you guys. So this is 2 times 1,000 plus 6 times 100. That's what 10 to the 2 is. Plus 4 times 10 plus 9 times 1. So that's 2,000 plus 600 plus 40 plus 9. So we have, 2,000. Then the next space is the hundreds. We do have 100 there. We have 600s actually. 2,600. Next space would be the tens. So we have 4 tens and 9 ones. So 2,649 is the number that's represented here. Okay, any questions there? One thing you do have to be careful with is don't just say, oh, I'm just going to write down 2, 6, 4, 9, I'm done. Skip all the rest of it. Nah, you can't do that because we have to make sure that all of the powers of 10 spots are in here. For example, D, look at how we're missing 10 squared and 10 to the 1 in this expanded form. So how do we deal with that? Well, this is how we deal with that. This is 7 times 1,000 plus 8 times 1. So that's 7,000 plus 8. There are no hundreds, there's 0 hundreds, and there's 0 tens. So we don't just write 78, that's not the answer. Instead, it's 7,008. Okay? So take a moment and just kind of let that sink in. Let me know if you have any questions about that or anything you want clarified there. No questions? All right. Well, I'll give you your assignments.